So now we're going to talk about the essential part of what you want to do with troubleshooting VLAN and switch problems. We're going to talk about some common, just general switch issues, common VLAN related issues, common spanning tree issues, and then finally some techniques regarding VLAN and switch troubleshooting. One of the things to keep in mind is just there are some things that can just generally happen on a switch. For instance, if you have a physical or connectivity issue, you're going to see one of a couple symptoms. Interface is down, down, meaning it's not receiving keep alives and it's not physically connected. Interface is up, down, where it's physically up, but the layer 2 protocol is down. And then obviously the interface is administratively down. This will be one of the things you'll just run into frequently. To address that, you start off first, this is always good, always start with assuming the problem is with a cable. Swap with a known good cable. You may, in some instances, substitute with a crossover cable. It may not have the auto MDIX crossover function. You may have to actually do something manually. And that's the case, just do that. Also verify the hardware is functional. You can, for instance, use show controllers to see if there's something physically wrong with it. Or try a different port on the switch to see if the same problem is happening. So verify your cabling. Also verify the interface is operational. Make sure it's up. And use the no shutdown command. I would obviously take care of administratively down, or if it's been put into error disable state because of one of the layer 2 protocols and so forth. Another thing that's going to happen is speed and duplex issues or mismatches frequently across two interfaces. This can be particularly true if you have gigabit connection on one side and a 10100 on the other. Here are some of the symptoms. First, you'll actually see a syslog message that says CDP for duplex mismatch. That's going to tell you that there's a duplex mismatch. If you have something hard-coded on one side and auto on the other, or you have them hard-coded on both sides and they're done differently, it's not going to be able to auto-sense anything. So you can have speed mismatches and duplex mismatches as a result. If that's the case, set speed and duplex settings to auto-negotiate on both ends, or make sure they're set for the same speed and duplex on both ends. Some VLAN related issues. You may have interface flapping on a port set for access only mode. And the way to solve this is first just do a show running configuration and verify that these entries are on the port that's affected. Switch port mode access and switch port access VLAN and the VLAN ID. If something's missing from that, add what you need, because some of the more automated types of things and automated trunking type of mechanisms can create this type of issue if you don't have it specifically set for access mode and the specific VLAN. Another reason why a VLAN could be down is because there's no physical port associated with that particular VLAN. Now with the layer 3 switch, this typically doesn't tend to be as big an issue. On layer 2 switches it can be. But when you do show VLAN, if it shows down, make sure there's at least one port in that VLAN or a switched virtual interface in that VLAN, and it should come up. Another common thing you can run into is VLAN trunking issues. You've connected the cables and it's not establishing a trunk across the link. The first thing you need to do is, if you're using ISL trunking, make sure the switch on the other side supports ISL. If it doesn't, then you're going to have a problem and you need to change that. If you're using 802.1q trunking and the trunking's not establishing, you may have different native VLANs configured on either side. And if that's the case, change the native VLANs to match. Also verify the trunking settings on both ends of the link are the same. Switch port mode trunk. The encapsulation, if you're using routers and so forth, make sure all of those match. VTP issues, and there can be a lot of issues with VTP, but typically it's going to be the symptom of VLANs are not propagating from servers to clients the way that they should be. The first thing you need to make sure is that both links on both sides between the client and the server are configured as a trunk. If it's not configured as a trunk, VTP is not going to work because it only goes across trunk links. So check that first. Make sure the type of trunking matches as well. Verify that the VTP domains match. If they don't match, VTP won't function either. And also make sure that the switch you want to be the master isn't still in transparent mode or in client mode. Make sure it's in server mode and that the other switch is in client mode. Make sure of those settings. Inter-VLAN routing. You have two VLANs set up and they can't reach one another. Now, this isn't within a VLAN because that'd be a trunking issue, but from one VLAN to another VLAN. For instance, in the picture, VLAN 1 and VLAN 11 cannot reach one another. If you're using an external router router on a stick, picture to the left, make sure that that router is first reachable. For instance, if VLAN 1, the workstation VLAN 1 can't reach the VLAN 1 interface on router 1, there may be a connectivity issue or a misconfiguration issue. If you're having some other issue, you may have to troubleshoot routing. But if VLAN 1 workstation can reach router 1's VLAN interface and VLAN 11 can do the same thing with router 1's VLAN interface, there may be something on the router you need to look at. If you're using a layer 3 route processor, make sure that the switch virtual interfaces have been configured. If they haven't, it won't work. So make sure that's correct and that the VLAN information and subnet information is correct. And you may also want to make sure on the switch that a default gateway exists. Spanning tree. Lots of things can happen with spanning tree. For instance, you may have a port that's gone into an error disable state or has become non-functional after some type of configuration. If you're using PortFast and you have, for instance, BipiDoGuard enabled, make sure there are no other devices creating those protocol units being sent to that port. Also, make sure no unidirectional links or one-way links exist. And in worst case, just do a shutdown, no shutdown on that particular port to restore service. You may have a problem with Ether channel. One of the things that you have to make sure is that Ether channel parameters have to match on both ends. They have to be the same type on the switch. Now, you can have a fast Ethernet on one switch going to a gigabit on the other, but if you have a fast Ethernet and a gigabit Ethernet configured on that switch to go to the other switch, it's not going to work. They have to be the same type of interface. And make sure the protocol is the same. Port aggregation protocol or link aggregation protocol. Make sure that they're the same on both ends. And also make sure that you've used identical trunking configurations, including native VLAN if you're using 802.1q. Now that you've looked at some common problems, here's some just basic ideas of how to do troubleshooting on switches and VLANs. Always start with the physical layer. Make sure the interface is up. Make sure the cabling is operational. That's one of the things that frequently can fail, and that's the first thing you need to do. You can spend a lot of time troubleshooting things when it simply comes down to a cable. The second thing to do is make sure you use Cisco Discovery Protocol to verify layer 2 connectivity. If you have it turned off, turn it on just for the testing purposes. Execute the command, show CDP neighbors, verify the device names you're expecting to see, and the types on both ends of the link. If there are no neighbors being shown and you have everything configured so that it should, you may have a layer 2 issue of some kind, and that can help you isolate to what layer of the OSI model it's going on. The other thing you need to do is make sure you look at ARP mappings. Use the show ARP command on both devices and look for either incorrect MAC addresses or a description of incomplete. If it's incomplete, you may have some other kind of issue. Also, to verify ARP mappings, issue a ping command to the IP address on the opposite end of the link. If the ping fails or the ARP entries are incorrect, you can then go to possible causes there, and it helps you isolate what may be going on. Now has come the time to actually look at how this works in a simulated, somewhat real environment. So we're going to do our VLAN and switch troubleshooting exercises. We're going to start with giving you a general background of some situation that could actually exist, and then there'll be 3 trouble tickets that then we will get from the system and use for troubleshooting and resolution purposes. We're going to do one on the internet is down, no connectivity, and network is slow. So just a little bit, this particular set of exercises is going to concentrate on the Site 1 that's a part of our lab. You see the topology to the left. This is the basic layout. And this particular environment is a large campus with 300 employees spread across 3 separate buildings, all owned by the same company. The internet connectivity is across the wide area network. So this campus environment is getting internet access from another location. And there are 2 routers that provided redundancy both to the WAN and the internet. Notice router 1-1 and 1-2. These both connect to the wide area network. Now here's the specific situation. This particular building that we're looking at, building 3, serviced by router 1-3, has been experiencing a number of service outages. Your role as a Tier 1 help desk technician on duty is to receive the trouble ticket, diagnose, and then solve the issue. So here's the trouble ticket. You, as a technician, you come in at 9:30, your scheduled work time, and you find a high priority trouble ticket assigned. And it says the internet is down. The problem has been going on for over an hour without any resolution. And you discover just from some investigation that someone on the network team has made an undocumented configuration change. which is one of the things that can frequently happen. So your task in this particular, or our task I should say, is going to pick up the ticket and assign it to ourselves, contact the requester and inform them that we're working on it, and then obviously perform troubleshooting and resolution. It's 8:30. We've come in and we actually see that there's some requests available. And here the internet is down. And this is from Yosemite Sam. He says, just as I was about to submit my monthly report to headquarters, the internet went down. This is the third time this week. Are you guys just sitting there drinking coffee all day or something? Get this fixed, you varmint. Now, while this may sound really harsh, you would be surprised at the number of times these sorts of things, tensions run high if something's not working, particularly if their job's dependent on it. So even if you don't particularly like the way this person is talking to you, you have to be able to take it into account. So it's already assigned to me as administrator. We talked about that before. So we've looked at it. The internet went down is the problem. The priority is high and it's currently open, meaning it hasn't been resolved. So here would be the point where we'd be able to send a note saying, hey, we're working on this. We're trying to take care of it as quickly as possible. You just say log a call, in fact, in this. Yosemite Sam. Here we go. And we could very easily just say at this point, hey, we're working on this, and so forth and so on. So we'll go back to the request screen. Got the internet is down again. So now obviously we want to be able to do something. So let's go to our console. Router 1-3 is where the problem is. So let's start there. So one of the things to do is to be able to see if we have connectivity. So first, we want to actually isolate the problem. So let's do show IP DHCP. We don't have a DHCP configured on here, but we can say that we understand that the workstations are actually still able to reach us. That's obviously because the trouble ticket came from the manager there saying that the internet's down, but everything else seems to be working, or at least locally. So we could start by showing the physical layer, IP interface brief. Let's see what it tells us. Okay, this interface is not being used, otherwise that would probably be something to look at. But notice here, LAN interfaces are up. So that's working the way that it's supposed to. The physical layer is working, so we could always do show interfaces. Fast Ethernet interface is up. That's very important. So that seems to be working the way things are expected. We actually have a plan that we're following, which is located here. We did the show IP interfaces brief. Now we can do show CDP neighbors. And switch 1-3 is the upstream switch. So we know that that is functional. So we've now ruled out layer 1 and we've ruled out layer 2. Now we'll actually do a ping test. Ping. Because this is VLAN 1 and VLAN 11 for this site, 192.168.1. We do 255, which will actually give us everything on this subnet. Let's see what comes up. So we see some traffic. Let's do 192.168.1.1, which is actually router 1 outbound. Now notice router 1, this is router 1 here, and this is where located in R1-3. That's successful. So that's good to know. Now let's see on the production VLAN, because this is just a management VLAN. Now notice here we have some sort of a connectivity problem. And one of the things we want to do is actually make sure that we can ping the upstream switch. So we could do show CDP neighbors detail, and it'll actually give us what the IP addresses are. Neighbors detail. And it's not listing an IP address here. Ping 192.168.1.1.1. 2.1.1.3. So we're not getting any connectivity to switch 3 because that's what these mean. This is switch 1, switch 2, and switch 3. We've got successful connectivity on VLAN 1 to router 1-1 and everything in between. We can get to just about everything else that we're supposed to, but we're obviously not able. We're going to do a ping to the internet now. 1614512. And again, so we can't get outside on VLAN 11, which is why the internet is down. Let's go back to our plan here. So let's check routing, because that's another thing we want to look at. Show IP route. It looks like we could potentially have a routing problem. Let's look and see what's here. Because this is supposed to be participating in EIGRP. Show IP EIGRP interfaces. So now look here. We have 0 peers, even though we can get out on our VLAN 1. The VLAN 1, again, is a management VLAN, the production VLAN. This is the one that's critically important here. But we are not getting any routing. So now we're not really sure, but it looks like this is a switch-related problem because of the way things are working. In fact, we did a trace 192.168.11.1. And essentially, it's not doing anything. So we'll go ahead and cancel out of that. So now we could probably figure out that the problem is not on this router. And since we did a show CDP neighbors and we know the next upstream is switch 1-3, let's take a look at that. Switch 1-3. So looking back at our plan, let's do show CDP neighbors. Router 1-3, which we looked at before. And we have an ether channel with switch 1-2 across these two interfaces. So we know that we're looking like a layer 2 connectivity is here. So let's do show interfaces or show switch port. So interfaces trunk. Now, native VLAN and native VLAN are matching. This is the link back to the router. This is the port channel that's up to the next upstream switch, switch 1-2. Everything appears to be in order here. Now we do show spanning tree. And we'll do VLAN 11. And we have our root port and our designated port. And so this seems to be functional. Now let's do show VLAN to make sure this has all been configured correctly. And we have VLAN 11, VLAN 1 configured. So it's starting to look a little strange. Let's check VTP. Show VTP status. Configuration is being successfully sent. Have our domain name, which is correct. It's operating in client mode. And 7 existing VLANs. So we've eliminated router 1-3, switch 1-3. Now we need to figure out, let's go out to switch 1-2. Show IP interface brief, which doesn't seem to be an issue. And the issues that we want to look at, notice our port channels. Show CDP neighbors. And wow, we've got all kinds of stuff. We've got switch 1-1, which connects out to the router 1-1 and outside. Got switch 1-3 that we talked about before, and even switch 1-4, which is a redundant path. So show spanning tree VLAN 11. And everything is doing exactly what it's supposed to. We've got our port channels, got everything else functioning the way it's supposed to, and everything appears to be going correctly. So let's make sure the VLAN's there. Show VLAN. You've got VLAN 11, VLAN 1, which are the ones that are critical. Now let's show VTP status. Okay, so we've got it's operating as client. It's getting information updated. I mean, it looks like everything should be working. But let's take a closer look. Look at this. These letters are in lowercase, and while it might not sound like a big deal, to this switch that means something different. So let's, now that we have identified a potential issue, we can try to figure out if this may be the reason. Remember, make one change at a time, because if you make 4, you're not going to know which one worked. So, configure terminal, Vtp domain CCNP TSHOOT. Now we can go back to our router 1-3, and as soon as we put that in, let's see what happens. The domain name's changed. We'll go ahead and close that out. So router 1-3, ping 192.168.1.1, which was successful before. 11-1. Oh, now look, it's back up. Logging on, in case the logging got turned off. Now show IP route. Show IP EIGRP neighbor. Still no neighbors, even though we've got connectivity again. So let's do another show run and see if something's out of order. Aha, look at this. On this particular interface, there's also been an error where IP authentication for EIGRP has been put in place. So let's take that out. Now look at that. Now we've had things come back up. IP EIGRP neighbors, we have the 3 that we're expecting. Now let's do ping 192.168.1.11.1. Now let's do the internet, 216.145.1.2, and our internet is back up. So we were able to, let's just do a little analysis on this, what I call a root cause analysis. The fault was identified on device switch 1-2. So we know what device was involved. The fault was layer 2 or data link layer in nature, specifically VLAN trunking protocol. If we want to get even more specific, it's the VTP domain name mismatch, which is what's here. And because it was an undocumented change, we could say that this is a human error. Or it could be that it would be a resume generating event. And then how was it corrected? By putting in the VTP domain name CCNP TSHOOT all caps. Now it's been resolved. We could go back now and we can edit this. It's resolved. And then we could obviously put in our notes what the cause was. We can do update. Now if we go back to home, now notice that has been resolved. And these 2 are still in queue, which is what we'll be working on in a moment. But that's how we were able to resolve this particular issue.